See how the idle speed is going up and down. We do have a check engine light on. Hey, what's up guys, your friend Jim here. Welcome to the Mitsubishi Montero channel. Well, it appears we have a little bit of an issue with the blue Montero. There it is right there. Started up in the morning and it's got like a low idle and a check engine light on. Let's see here. Let's see if I can duplicate the issue. See how the idle speed is going up and down. We do have a check engine light on. The idle is surging up and down. And we do have the scan tool hooked up here, which I already had hooked up, and I was looking at the data. But before we get into the data, let's go back. Let the scan tool connect here. We're gonna go back and we're gonna go to diagnostic trouble codes, and we're gonna read the codes. And we have a P0102, mass or volume airflow circuit low input. That's a confirmed, and the pending, it's exactly the same one. So we have the P0102 pending and confirmed. And if we go to the freeze frame data for the code, let's see here. We go for the freeze frame data for P0102, and we have obviously it's an open loop, it's cold. Calculated load is 0, which should not be 0. Map sensor is 12.7. Engine speed is 648. Vehicle speed is 0. The computer is backing up off the timing. It's -8 degrees, but the mass airflow sensor is 0. So mass airflow sensor is reading 0 right now. Now I'm gonna go back and I'm gonna go to data stream and look at the live data. And it's still doing the thing, still surging, maybe cycling between 700 and 1100 RPM. Check engine lights on. And let's look at the data. And on the data, I do want to see, I am seeing the calculated load is 0. The ignition advance is cycling between -8 and -1, which is kind of weird. I haven't touched the accelerator pedal, but the mass airflow sensor is reading 0. So that is weird. It's not supposed to be 0. So let's take a look under the hood, just do a visual inspection, see what we find. Okay, so it appears that the RPM is already stable. It's not cycling up and down anymore. But if we take a look at the scan tool data, check engine light is still on. RPMs are stable at 1000 RPM, but we still have 0 for the mass airflow sensor. So there's still something going on there. Now, everything here seems to be normal. Just a quick visual inspection, everything seems to be normal. With the airbox, nothing out of the ordinary that I can see. So what I'm gonna do is we're gonna check the wires that pertain to the mass airflow sensor signal. Alright guys, so I do have a couple of known good mass airflow sensors here. So you have this one and this one, plus I have another Montero that I could just swap out the mass airflow sensor. But we're not gonna do that. We're gonna diagnose this thing, okay? It's reading 0 for the mass airflow sensor input to the computer. So why is it reading 0? So let's go ahead and get to the bottom of it. What the cause of it is? Is it a bad mass airflow sensor? Let's get to the bottom of it. But we're gonna do it the right way, the diagnostic way, not just throwing parts at it, okay? We could do that, that's the easy way, anybody would do that. But for this video's sake, let's go ahead and do it the hard way. What do you guys say, huh? Let's go. So first thing to do is, I already have my meter here, and we'll go through some of the voltages later, but the first thing to do is identify each one of these terminals. Each one of these terminals has its own particular function and purpose, and we're gonna go over that right now. All right guys, so I did change the lens on the camera so you can see close up on this wiring diagram, but it's just for close up, because if I point it to myself, it makes me look like Gollum in the Lord of the Rings when he puts the ring on, so everything else looks blurry. But anyway, so let me set up the camera here, put it on this side. And let's go over the wires here. We have green with a yellow stripe. Wait, I don't like this setup. Hold on. All right, guys. So I just brought the camera and this diagram inside here in my work area. A little bit better over there. It's a little windy and a little disorganized. So I think it would be better if we go over the circuit here, and then we'll go out there and check it out. Now on the computer screen right there, I do have a picture of the mass airflow sensor. So as you can see, when you're looking at the mass airflow sensor on the car, you have this connector. It's a 7-pin connector that goes from left to right, 7 pins, and it's basically this connector right down here, 7-pin connector. So on the left side, oh shoot, okay, so on the left side we have the green with the yellow stripe, then on the going to the right we have the green with a white stripe, this one right here, and then we have a white with a black stripe, and we have the red wire. It's a little bit thicker, and that comes from the MFI relay, so that's got power. Then we have terminal number 5, which is this sky blue. It's basically a light blue wire. Call it sky blue. And we'll talk about each one of these. The next one, terminal number 5, is a, wait a minute, no, I'm sorry, terminal number 6 is a red wire with a blue stripe, which is right there. And then the last one, number 7, is a green wire. Okay, so if we look at the wiring diagram, we can see that, hang on, let me put a flashlight here so you can get better lighting. Okay, so that should be okay. So here's our mass airflow sensor. As you can see here, here's terminal number 1. Let's just go one terminal at a time, and then we'll go out there and check it with the voltmeter. So this is a 5-volt reference. You see the 5 volts here. 5 volts comes out of the computer. It goes to this splice point. It goes to the map sensor. It also goes to the accelerator pedal position sensor and some other components. But this is basically a 5-volt reference. So terminal number 1, green with a yellow stripe, is a 5-volt reference. Terminal number 2, green with a white stripe, that is your barometric pressure sensor signal. That's basically the altimeter, whatever you call it. It tells the computer your elevation. At sea level, we're talking about should be anywhere between 3.7 to 4.3 volts. At 5,000, when you go to Big Bear, you go to the mountains, 5,000 feet of elevation, that voltage will be 2.9 to 3.5. So that's basically the barometric pressure sensor signal that goes into the computer. Terminal number 3 is over here on this side, and this is a white with a black stripe, and this would be your airflow sensor signal, mass airflow sensor signal coming out of your mass airflow sensor, going to the computer in the form of a waveform. Basically, it's a 5-volt on-off signal, but it changes frequency depending on the airflow that's going through the sensor. And that is that is how the master flow sensor sends a signal, the master flow sensor signal, out to the computer. If you just check the voltage on this signal, it is going to be 2.5 volts, around 2.5 volts, because it's just a 5 volt circuit cycling 5050. So your voltmeter will average it out at 2.5 volts. We'll double check that right now. But terminal number 4 is basically it's up here. It's the red wire that we talked about. This is the power supply coming in from the MFI relay. Terminal number 5 is the sky blue wire, light blue wire, and that basically goes to ground. It goes to ground. It goes to another terminal here. If you see this, it says 7Q. So if you, right now we're on page number 9 of this wiring diagram. If we go to page number 7, we'll see the continuation of that right there, of that terminal. And basically that terminal goes into the computer, and then through the computer it goes to ground. So that's basically a ground circuit. The sky blue wire is a ground circuit. Terminal number 6 is your intake air temperature sensor. So that's basically your thermistor inside the master flow sensor, telling the computer the temperature of the air that's going in there. Okay, and then terminal number 7 is very interesting. I'm not 100% sure what terminal number 7 is, but I'm thinking it's a confirmation signal. It's a confirmation signal going back. So basically the master flow sensor sends a signal to the computer, and the computer recycles that signal back to the sensor, almost like a closed loop, saying everything is cool here, everything is cool there. That's what I'm thinking it is. So I'm thinking the same signal we see here, that's the signal we're going to see here. I've seen other circuits perform this way, but I can't find literature saying that that's what it's for. I'll have to dig a little deeper. So let's go ahead and go to the sensor and check at least some of the basics here. Let's check the 5 volt reference. Let's check the ground. Let's see what we have on these guys. Make sure there's no continuity to ground. Make sure we have voltage here, power here. Number 1 thing to do is check the voltage on the red wire. So we're gonna back probe right here and see what we get. Oh, come on. Okay, so we got 14.2 volts on the red wire, and we're just back probing with the sensor still plugged in, engine running. Okay, I got a better back probe here. I got a better back probe. So on the red wire we have the 14.2 volts, and I'll make a note here on the sheet of paper. 14.2. Let's go to terminal number 1 and see what we get there. Terminal number 1. And we have 5.0 volts. So we have 5.0. Terminal number 2, which is a green wire with a white stripe, and that's your baro. Remember we talked about the barometric pressure sensor. So at sea level, we're here in Redondo Beach, so we are at about sea level, and we're expecting to see about we have 4.0 volts, and remember the range for that was 3.7 to 4.3. So we're at 4.0, which is perfect for a barometric pressure sensor signal. The next wire is terminal number 3, which is the white with the black stripe, and that's the signal. But before we get to that one, we're going to go to the sky blue one, which is this one, which is the ground. So that one goes through the computer, and then it goes to ground. And on the ground, we don't expect to see no more than 50 millivolts. So we have okay, so we have 67, we have 68, 69 millivolts. It's a little bit higher than I want to see, but it's still a ground, you know, it's still a ground. So we'll keep an eye on that. I'll make a note of that here. So the sky blue, we have 68 millivolts. The barrel, we had said we had 4.0, and we'll go over these on the bench over there. So these are the important, so those are the first 5. So now these are the signal, the master flow sensor signal wires. Terminal number 3, which is the green with the white with the black stripe, and that one, remember when I told you guys that's a frequency output signal. So we're expecting 2.5 volts on that, but we have 5.0 volts. Okay, so it should not be 5.0. That means there's no signal coming from the sensor back to the computer, but it does have the 5 volts going from the computer to the sensor. Okay, so now let's look at terminal number 7, which is the feedback signal. This is a green wire, solid green wire. And then we'll go back in and talk about these guys. So this one is kind of weird because it has 159 millivolts, but the little bar graph at the bottom, you see it going back and forth. That means that there is some kind of cycling going on right there. Okay, so we'll just write down 159 millivolts, and then the white with the black stripe, we had 5.0 volts, and we'll double check that one just to be sure. Yep, see 5.08 volts on the signal wire. Right now, based on this test, it shows that it's a bad mass airflow sensor, but let's just follow the next step here. All right guys, I forgot to check terminal number 6, which is the air intake. Terminal number 6. I'm expecting about 2.5 volts, something like that. So we have 2.23 volts. 2.23 volts on terminal number 6. All right guys, so in conclusion, this is the results that we got. Terminal number 1, it's a 5 volt reference, so we did get the 5 volts there. Terminal number 2, that's the barometric pressure sensor signal, and we did get the 4.0 volts barometric pressure signal based on sea level. Well, that's within range. Terminal number 3, which is the sensor signal, we got the 5 volts on that signal. This wire should be cycling on and off based on this transistor, so we should have gotten like 2.5 volts on there. So there's no signal going on in this wire, but we do have the 5 volts coming from the computer that are making it to the mass airflow sensor. It's just that the mass airflow sensor is not generating a signal, which lets us know that this wire is okay between the sensor and the computer. It's not shorted to ground, or it's not an open circuit. So we're dividing and conquering this circuit just based on that knowledge. Terminal number 4, we got 68 millivolts. I was expecting no more than 50, but you know, we'll just we'll keep an eye on that, but it's still a ground. Terminal number I'm sorry, that's terminal number 5. Terminal number 4 is battery voltage from the MFI relay, and then terminal number 4 is a ground. Terminal number 6 is the intake air temperature sensor. We got 2.2 volts on there, so it's completely normal. It's just going based on that thermistor, letting the computer know the temperature of the air that's going into the engine. And then terminal number 7, as I mentioned before, it's like a feedback type of signal. That one we got 159 millivolts. I'm not 100% sure what's normal on that wire, because I couldn't find it on the on the repair manual. But once we install the new sensor and we fix this issue, then we can confirm if that's normal or not. All right guys, let's keep going here. All right guys, so basically in conclusion, based on the testing that we've been doing on this, we have concluded that the mass airflow sensor is not generating an output signal back to the computer. And that's the reason why the check engine light's on. The computer doesn't know how much air is going into the engine, and that's the reason why it's surging on cold startup, and why we have a 0 on the mass airflow sensor on the data, on the Scantel data. So I do have a couple of sensors there. I know they're good. Actually, this is not even the original one for this Montero. It's another one. So we're gonna put another sensor We're gonna take this one off, and maybe we're gonna inspect it. Maybe there's a leaf stuck in there, maybe there's something else going on that we don't know yet. So I'm gonna take this apart, and we're gonna do another visual inspection, which is probably something you're supposed to do before we do everything that we just did. But for the sake of this video, we just went through that. That way you guys know how to do it, all right, and know what's normal. All right, let's take this off. Alright guys, so everything seems pretty normal. So once again, everything seems pretty normal. So here's another sensor. This one I got from the junkyard recently. It's the same part number, obviously, as the other one. So let's try this one out. I do have another one. I do have this one that I think I also got from the junkyard, but this is like a brand new one. Look at that. This one, they had just replaced it on that car before they junked it. So this is a new one. I'm not gonna use this one yet. I'm gonna try this one, and then we'll go from there. Alright guys, so we got the sensor installed. Let's go ahead and start the engine and see what happens. We may have to go through a clearing of the code cycle, but I just want to see if it still reads 0 on the mass airflow sensor data. Okay, so now it seems like a better startup. Let's look at the data here. Okay, see, now we have 0.70 coming out of the sensor. So now everything is back to normal. Now the computer has a mass airflow sensor input, so that's obviously a bad mass airflow sensor, which is weird. Anyway, I'm gonna go ahead and clear the code. We still have the check engine light on there, so codes, erase codes. Are you sure you want to erase codes? Yes. Press enter to continue. Check engine light's gone. Let's just go ahead and cycle the key once. And we are back to normal. Alright guys, so now that we have a good sensor that's not setting the DTC, let's go ahead and check the results again on the voltage. So again, here on terminal number 1, we have 5 volts, 5.1 volts. Terminal number 2, we have 4.0, normal because of the barrel. Terminal number 3, which is a sensor signal, now we have 2. See, now it's reading a little bit different. Before we had a solid 5 volts. Now we have anywhere between 2.4 to 3.1, and it's kind of going back and forth. You can see the little bar graph right there going back and forth. So we have some kind of frequency going on that signal now, whereas before we had a solid 5 volts. So now we have anywhere between 2.4 to 3.0, and then of course we're cycling. All right, so that's good. That's good. Now this is normal compared to the other stuff, the other voltage reading that we got before. Now on the red wire, terminal number 4, coming from the MFI relay, so we have battery voltage, so we have just B+ right there. The sky blue wire, which is at ground, and we have, see on this one we have 107 millivolts. That's more voltage than I care to see in there. So 107 millivolts. I'm expecting no more than 0.05 there, or 50 millivolts, but I'm not sure why we have so much voltage there. But we're just gonna keep that in mind. terminal number 6, which is the air temperature sensor signal, we have 2.3 volts, which is normal, 2.3. And then the other terminal number 7, which I believe is the confirmation signal going back to the sensor. That one, now we have, similar to what we had before, we have 196 millivolts, and we do have that little bar graph cycling, like there is some kind of frequency going on. So it's acting similar to the other one. The big difference is the signal wire that I just talked about. Alright guys, so just to briefly summarize on the mass airflow sensor testing results. So again, we have the 7 terminals. Terminal number 1, green with yellow, that's a 5 volt reference, and we got 5 volt reference all across, normal reading. These are the results with the bad sensor, and then these are the results with the good sensor. So terminal number 2 is the barometric pressure sensor signal. Terminal number 3 is the mass airflow sensor signal. Number 4 is power from the MFI relay. Number 5 is the ground. Number 6 is the intake air temperature thermistor signal. And number 7 is what I pretty much call the confirmation signal, feedback signal going back to the sensor, I believe, from the computer. But we'll talk more about that in another video. Anyway, the main takeaway here is that with a bad sensor, we had 5 volts on the mass airflow sensor signal wire, and we just had a solid 5 volts. Though that voltage comes from the computer, and the sensor uses an internal transistor to turn it on and off, and that's the signal going back to the computer. Based on the little bar graph at the bottom of my meter, we had 0 hertz. We had no cycling, no frequency. So that was the main difference between the good sensor and the bad sensor. Once we put the good sensor on there, we didn't have 5 volts there anymore. We had anywhere between 2.4 to 3.0, and we did have that little bar graph at the bottom of my meter kind of cycling back and forth, indicating that there was some kind of frequency on there. Everything else was pretty much the same on all the other terminals. The only terminal is terminal number 3, the white with the black stripe. That's the one that gave us the false reading. When we initially checked it and we got this result, we knew that that was indicating that it was a bad sensor, because the voltage, the 5 volts, comes from the PCM, and the fact that we have 5 volts making it to the sensor means that the wire is not broken and that the wire is not shorted to ground. So that told us right away, yep, you got a bad sensor. So I hope this information helps you guys, as far as like if you have a P0102 on your car, or if you have any idling issues. That's always a good thing to check. I'm still a little bit skeptical here on the ground. Why do we have 107 millivolts on the ground? That should not be like that. It should be way less than that. So I'm still gonna keep an eye out on that, but for now we're gonna call it good to go. All right guys, I got the old mass airflow sensor here. Has anyone taken one of these apart? Should we take it apart and see if we can see what possibly failed? I know it's got these 2 screws here, but I don't think that'll do anything. I think we have to take this little cover off, and it's got these little holding tabs right here. So let's see. Woo. Oh, look at this. Oh my gosh. I don't see any burn spots or anything like that, but wow, look how sophisticated this circuit is, this sensor. There's so much going on in there. And so this is like 3 sensors in one. Baro, airflow, and air temperature. That's how sophisticated this thing is. Damn. Anyway, guys, I'm gonna keep staring at this for a little while, so we'll see. All right, guys, look, I found where the issue was. I don't know if you could tell, but you see this resistor right there, this guy right here, that resistor is burnt. There's like a little burnt spot right there. I don't know how well this GoPro is focusing. There's like a burnt spot right there. Anyway, so I'll put a close-up picture here. You can see it better on that area where that resistor seems to have gotten a little hot there. Alright guys, well that pretty much concludes the video. I hope you enjoyed it. Thank you so much for watching. We'll see you on the next one. Appreciate it. Bye.